That's why it's not rectangular. It's not rectangular. It's like a pennant.
It is. It's like a triangular.
It's not perfect. It arrows in and then it has two points.
But that's not, no, but the actual word Ohio has a characteristic. Yeah, horizontal reflection.
I never got that one. Oh.
It's like on the border with it. Oh yeah, the line, right? So 17. They're asking you to estimate the slope at part A 47.5, which would be right there. We don't have that point available, so we choose like the two that are closest. So I'm going to use these two. So y2 minus y1 would be 36 minus 21. x2 minus x1 would be 50 minus 45. So 15 over 5. And if you're feeling... The label is goofy though, it's not as expecting, that's why it's not. If you're feeling arrogant, you could do 15 divided by 5 and get 3. Sure. What's the label though? What is it? Yes. So we are at, they're telling us P of T is pages per day, which is unusual. Usually the pages per day would be the derivative. Set it up however you want. So they're setting it up so pages per day is P. And every time you go down a level, you add a per whatever, you know, like meters per second squared. The label here would be pages per day squared. Or someone said it like this too. You could do like pages per day. Per day. Those are both the same thing. The acceleration in your reading. He's reading faster and faster. He's learning. The machines are gaining knowledge. And then part B is doing it at 9, so you're doing the same idea. You use those 2 points. So 20 minus 51 over 13 minus 5. So negative 29 over 8. So he's reading slower at first and then faster. And then that'd be pages per day squared. Max, how's that? Is it the label that was throwing you off? Or give me a little bit of a kind of freaked out for a second. Arrows? Alright, let's go to 4. Don't worry about that top part. We're not going to do it. So differentiable. So differentiable just means like you can take the derivative. So there's certain situations you cannot take the derivative. That's what we want to go through. So you cannot take the derivative if the function has a cusp or a corner. So a cusp, I don't really know this word. Like that. It's like two curves that come together to a point. Corners, obviously, something like that. Or it could be like a combination of both. But the idea is like the same as limits. If I ask you for the slope here, because the derivative is slope, right? So if I ask you for the derivative or slope here, you can tell me. If I ask you for the derivative or slope here, you can tell me. If I ask at that point, you wouldn't know which one to pick. So now limits have to be the same for both sides. The derivative has to match for both sides. The slope has to be the same. So this fails to exist because slopes are different from left to right. From each side. From the plus and minus or whatever. second way it could not be differentiable is a discontinuity. There's three types of discontinuity. You have the whole, which is what kind? Movable. Got something like that, which is a jump. There's one other type of discontinuity. Vertical asymptote. So vertical asymptote. So the third type. The third type is not a vertical asymptote. It's different than a vertical tangent. If your graph went like this, that goes backwards. I don't want to go backwards. I'm trying to draw, so it goes like vertical for a second and then continues on its way. So like at that spot, imagine that spot is vertical. That's what I'm trying to accomplish. So your surfboard, if you're going along this curve, your surfboard will be pointing straight up. So if we're straight up, what's the slope? Undefined. So what's the derivative? Undefined. Slope and derivative are like the same idea. So if the slope is undefined, that means it's like something over zero. If the slope is undefined, so is the derivative. So the slope and derivative are undefined.
If it goes vertical at any point, is it still a function? Because like
So it can like go infinitely vertical for such an infinitesimal small amount that it's just like, so like y equals x cubed. We're gonna do horizontal instead of vertical. That is horizontal at like 1 point only. So like the y equals x. This one, if it goes like this, I didn't draw that right, but it's really just at that one spot. So people very often, so if I ask you on the quiz for like the three discontinuities, I very often get this: a cost per quarter, a discontinuity, and a vertical asymptote. A vertical asymptote is a discontinuity, so you're just like listing it twice at that point. So make sure you understand the difference between a vertical asymptote, where your surfboard comes in, a vertical asymptote, which is where you can't touch it, and a vertical tangent, which is where your surfboard would be vertical. So I'll write that as a vertical surfboard. But Jason, there can also be ones that like are functions. Okay, so let's look at an example down here. We're going to go through it two different ways. I want to write first where the function is. Let's just go through each point. Right here. X equals -3. Is that a discontinuity? Yes. That's a whole, right? Is it differentiable? Is it differentiable right there? No, why not? It's a discontinuity, right? Doesn't exist. So this is non-differentiable. So because it doesn't exist is a good answer also. Non-differentiable works too. Let's go to x equals -2. Is that a discontinuity? What kind? That's not what I'm asking. I'm not asking if it's differentiable. I'm asking if it's a discontinuity. It's not a discontinuity. It's not a whole. It's not a vertical asymptote. It's not a jump. So this is not a discontinuity. But is it differentiable? No, because you got a corner there. So this is not differentiable. But it is continuous there. issues there? Everything's fine there, right? It's continuous, it's differentiable, it's nice and smooth, everything's good. X equals 2. Is x equals 2 a discontinuity? Nope. So it's the same as negative 2, basically, right? Not a discontinuity, but it would be not differentiable because you got a quarter. Then we got x equals 4. Another potential issue there. Is x equals 4 a discontinuity? Is what kind? Jump. So it's a discontinuity. Non-continuous. Discontinuity. And is it differentiable there? Can I take the derivative? I cannot. Non-differentiable. So one of those is true, one of those is false. Think through which one's which. And if it's false, give me a counterexample that like proves your point. So differentiability implies continuity. So if it is differentiable, if I know I can take the derivative, that's fine. Does that mean we already know it's continuous? It does. In order for it to be differentiable, it can't be a cos squared corner, it can't be a vertical tangent, and it has to be continuous. So if it is differentiable, you know that it is also continuous. I guess that's probably written true instead of yes.
False.
True or false? Yes. Sure. Continuity implies differentiability. So if something is continuous, it doesn't automatically mean you're going to take the derivative. It does not, and what would a counterexample look like? Like a cos for a quarter. Like that's continuous. I didn't pick up my pen, but I can't take the derivative at that spot. So this is no or false. Questions on this? I think it's too bad. That's it, right? Is that it for my part? Alright. I'll see if there's any you're supposed to skip. Otherwise, you just start working.
Because it rhymes with Monday. I was just. Yeah, I'm just saying what it is now.
But I was actually like impressed. It was him. There were two people in my corner talking. I couldn't tell who it was. And I was like, one of you, I don't know which is which, but one of you needs to come into the front. And he got up right away.
It's like a new person right there.
Really?
I know.
Do 1, 2, and 3 and check them, but I don't think we need to spend too much time on this. But I think it's a lot more fun. Start with 2, 5. You made it so fun. See.
Yeah, see there.
Are we still like listening?
I'm going with I'm right.
Are you with Russ?
I'm going with I'm right.
Sorry.
He thinks that this is undefeated. But if it's continuous, then nobody thinks this is
It could be continuous. Oh, I thought you said you're arguing with
no,
Wes.
me and Wes were
Oh, you're arguing with 3s. Does that make sense?
so loud. His cough drops.
I'm not even worried about the test prep for 2, 4. Okay, can we go 2, 5? 2, 5. You passed 2, 5?
I didn't do the last two problems, but I'm just hoping.
Okay, so this is where we actually like start taking derivatives, and we'll be doing this for 2, 3 weeks. Then we take what's called the gateway. I don't know if you guys heard of that from last year or anything. So the gateway is I'm going to give you 10 this came from like when I was at UNM. Like when I took intro calc, you took the class and you got a grade. But you had to go take this called the gateway, so I had to go to like this other building, it was like a mile and a half across campus, and take this test that was like the basics of the course. And if you didn't pass it, you wouldn't get the grade that you earned. You would just fail. So like I earned my B, but in order for that B to go on my transcript, I had to pass this test. So I can't do that in here. That's not how it works. Yeah, that's not. But I'm trying to like approximate it. So I'm going to give you 10 questions. There is no partial credit. You can turn it in. I'm just going to mark the ones wrong. But you get 3 attempts, and I'll take your best score. Fair enough. Doesn't matter if it's fair enough. No. So like you'll take it the first day stuff. So this is like the stuff we just did 10 minutes ago is not derivatives, but that could be. That's big. And we'll practice it, like you'll have a review beforehand. Alright, so this is like starting to actually take derivatives. So if I have x squared, we've talked about this a little. Do you guys remember what's the derivative? 2x. Derivative of x to the third would be 3x squared. So if I want to jump to the, maybe I'll jump to the rule and then go back. Bring down the power, and then you would multiply, if there was a number in front, you'd multiply it, and then you reduce the power by 1. So that at 5x to the fourth, the 4 would come down, leave the x there, reduce the power by 1. X to the fifth, the 5 comes down, leave the x there, reduce the power by 1. So this is instead of like the difference quotient. So the f of x plus h, when you did all of that, like half a page worth of work to get the answer. This is what we're doing. So a basic example would just be something like this, where you just bring down 37, put the x, reduce the power. You're not going to get very many questions that are like that. So this would be 9x. Yeah. But again, you're not going to get very many questions like that. You will get a lot of is things in different forms that you have to rewrite and kind of manipulate to be in a form that you can take the derivative of. So that's what these are. So 1 over x, I don't want a fraction if I can avoid it. If there is a fraction, I have to use what's called the quotient rule. The quotient rule kind of sucks. So if I can avoid it, I want to. Is there a way I could write x or 1 over x in a different way so it's no longer a fraction? X to the negative 1, right? So that would be like to rewrite it. Now it's in that form where I can just bring down the number, put it in front, and then reduce the power by 1. So be careful. When you're reducing a negative 1 by 1, where do you go down? Negative 2. Don't tell me 0. And then what they're saying here is now rewrite that so there are no negative exponents. So this would now be y equals negative 1 over x squared. So like on the gateway, this is part of the reason I do this is because I get this all the time. Like someone will do this. Like the answer is supposed to be this, right? Someone will do that, and I'll be like, well, here's why it's supposed to be negative. And they'll say, it's just a negative sign. Like, I got it. It is a big deal. That's wrong. So I think sometimes, and I do too, you tend to gloss over, like, that's not a big deal. I understand. That's fine. But that does lead to a wrong answer. So just be very careful. Second one, so how can I rewrite that? Yes, number 4. X to the negative 4. Now use your rule. So bring down the negative 4. Reduce the power by 1. And then rewrite it so that there are no negative exponents. On a free response, like they don't really care. You can put either one of those. They usually have the multiple choices though. The variable on the bottom. So I'm just going to go through both ways. Try the next two. First time. You want to try or you want me to? First person to speak gets their way. I was like, rock, paper, scissors. Yeah, rock, paper, scissors.
Best of I knew it.
What was your answer?
Try.
Okay. I mean, I'm going to go through it anyway.
It's not first.
If you like it, you go through it first. excuse me, I said there isn't one. Alright, so the rewrite here would be x to the 1/2. So it's always, if you have like the a root of x to the b, it's always the inside over the outside. And then if there's no number on the outside, it's a square root, right? So it's a 2. So it's like the inside power over the outside power. Differentiate, so now I'm going to bring down the power, leave the x, and reduce the power by 1, so it's negative 1/2. Then if I rewrite it, it's going to look like this. So the 1/2 kind of establishes your fraction. That x to the negative 1/2 is like floating, so it's on top right now. So to move it to the bottom, I make it positive. The 2 was already down there, so it's just like putting another with the 2. Questions there? So for 6, I'm just rewriting it. So is that x to the 3/7 or 7/3? 3/7. Inside or outside? And then you bring down, so 3/7 x. Reduce the power by 1, so you're doing like 3/7 minus 7/7, which would be negative 4/7. And then simplify so there's no negative exponent. You would have the 3/7 kind of establishes your fraction. That's on top right now with the negative exponent, so I'm going to put it on the bottom with a positive exponent. Questions on those? 6?
Yeah, how did you go from like 1/2 x to the -1/2 to this?
So the 1/2 is just fixed. Like that's just locked in. That's a fraction. And then this, because it's like floating right now, it's on top. It's not in a fraction. So I want to put it on the bottom. The way I do that is change the exponent to positive. And I just put it on the bottom that's already established. So, yeah.
It's okay to like leave the fraction exponents, is that? Like you don't want to write numbers for
Correct. Yes. I think that's like preferred.
Oh, okay.
Square roots are not.
This looks awful.
Yeah, it's not. Alright, I think there's a couple more for me. 7 and 8. This is not any different, but there's like more simplifying before you do it, which kind of mess people up. Let's review for a second. If I'm multiplying the bases together, I have like, we'll make it easy numbers, it's not fractions. What's that? X to the 9. You have 2 of them there, you have 7 of them there, so now you have that. What about that? What about that? 1 over x to the 5th, or x to the negative 5th. What about that? X to the 10th. Okay.
It's just whatever you touch.
I thought I could like circle everything. So the hard part of these for most people is the simplifying, not the calculus. I would rewrite this as like x over x to the 1/2. Because the square root of x is the same as x to the 1/2. And then when you're dividing the same base, you subtract the exponents. So that really just turns into x to the 1/2. And then I do my derivative. 1/2 x to the negative 1/2. Now be smart here. They're not asking me for a simplified answer. They didn't say anything about, like I don't even need, they don't even need this. What they want is the result when you plug in 7. They don't care if you simplify this first or not. So do whatever's easiest for you. For most people, that is just plugging in 7 right now. Like, don't simplify it. So I'm just going to go 1/2 times 7 to the negative 1/2. And that's like all I can do without a calculator. You're done. But if they ask you to plug in before you simplify is usually better. It's just less chances to screw up. Right, 8. I hope that comes out the way I think it does. So this is really like x to the 1/3 times x to the 3rd. So if we're multiplying the base, what do we do with the exponents? Add them. So that's like 1/3 plus 9/3. Now I have x to the 10/3. So now my job is to take the derivative, so f prime of x, so bring down the power, so 10/3 times x, and reduce the power by 1. So if I take 1 away from 10/3, yeah, it's really like 10/3 minus 3/3, right? So it'll be 7/3. And then I'm supposed to plug in 8, which I'm not going to fully do, but I want to talk through it at least. Like without a calculator, you're just kind of stuck there. If you had a calculator, you could just type it in. But I do want to review, so you get stuff like this a lot. Like 8 to the negative 2/3, let's say. I can't remember if we talked about this year in this class. Usually when we get to about here, people are like, wait, I need you to review that. So remember that the root is on the bottom. And you do that first. So the third root of 8 is like what number do you cube to get to 8? 2. Then you do it to the power. So you take the 2 that you have and you square it. So now we're at 4. And what does the negative sign do? The negative exponent do? Flips it over, so now it's 1/4. So try this. Try 16 to the negative 3/2. You just throw me out the window? Wow. Sandberg, I was physically threatened by a student. Yeah. I think he likes you better. So, bottom is the root. So what number do you square to get to 16? It's 4, then you take it to the power on top, so 4 cubed, 64, and the negative exponent flips it upside down. Alright, I do want to do 9, but tomorrow. I just wanted you to work on like the mechanics of it today. So you're only doing